Today we'll learn Lesson 4 of Unit 4, Inequalities of Combined Functions. First of all, let's have a look at today's learning goals. After this lesson, you are expected to be able to understand that solutions to problems involving combined functions can sometimes lead to a range of acceptable answers. When this happens, techniques for solving inequalities are applied. Second, understand that there are a number of ways to graphically illustrate an inequality involving a combined function. Next, understand that algebraic and graphical representation of inequalities can be useful for solving problems involving combined functions. So again, let's use some example questions to illustrate these concepts. First, let's have a look at this question. We are given two functions, fx equals x and gx equals x minus 2 to the power of 4. Then solve the inequality fx is greater than gx. Okay, I'll give you 10 minutes to think about this question first, and then let's have a look at the solutions together, okay? All right, let's have a look at the solutions together. So first of all, we can solve this problem algebraically, right? So we want to solve this inequality. Fx is greater than gx, right? So this is equivalent to fx is x. So x is greater than x minus 2 square, right? And we can further simplify this to x greater than x squared minus 4x plus 4, right? Which is equivalent to x squared minus 5x plus 4 less than 0, which is equivalent to x minus 1 times x minus 4 less than 0, right? And note that this is actually a quadratic function, which has a sketch of graph like this, right? There are two zeros. One of them is 1, the other one is 4. So the interval that makes the function less than 0 is x must be greater than 1 and less than 4, right? So this is a solution we are looking for. Okay, any questions? You can also check the solution here in this lecture slides, okay? And there is another method to solve this question, which is solve it graphically by considering the graphs of fx and gx, which is illustrated in this lecture slides. So first of all, we can sketch the graphs of fx and gx on the same 2D Cartesian plane, right? So as you can see here, this is our fx, which is the red curve, right? And the blue curve corresponds to gx. Second, we can then find the x coordinates of the intersections. So we have two intersections from this graph, right? One is here and the other one is here. In order to find the x coordinates of the intersections, we can just solve this equation, right? We can let x equals x minus 2 squared, right? And then solve for x. This is not difficult, right? Because this is actually a quadratic equation, which can be easily solved by using factoring or the quadratic formula, right? Okay, so by using the factoring method, we can see that there are two intersections with x coordinates of 1 and 4 respectively, right? So this is solutions of the equation. And then according to the graph, the interval that makes fx greater than gx, which means the red curve must be above the blue curve, right? So only in this interval here, the red curve is above the blue curve. So the solution of this inequality is from 1 to 4, exclusive. Understand? Okay, you can check the solution here on this lecture slides here, and let me know if you have any questions, okay? So in a summary, you can either solve this question algebraically or graphically. You can choose either method you like, okay? All right, let's continue. And let's have a look at another question. Solve the inequality sine x greater than log base 10 of x. Okay, this time it seems that it's not very easy to solve this inequality algebraically, right? So probably we'll consult some technology such as a graphical calculator or some online tools, right? So first of all, I'll give you 10 minutes to think about this question, okay? Okay, so let's have a look at the solutions. So in order to find the solution of this inequality, first of all, we'd better use a technology to graph the to sketch the two graphs of these two functions, right? One of them is y equals sine x, the other one is y equals log base 10 of x. You can use a graphical calculator or some other technology. So here I'm going to show you, I'm going to use the online tool here, which is Wolfram online graphing tool. So let's go to this website and we can just use a plot command and let's say this is sine x greater than log base 10 of x. And then you can see here, it plots the two graphs of these two functions. Okay, I'll show you on this lecture slides. This is actually the two graphs of these two functions, right? So as you can see here, there might be one, excuse me, 1, 2, 3 intersections, right? So next, we need to find the x coordinates of these two intersections, right? So again, we can use the online tools to solve the equation, which is sine x equals log base 10 of x. Oh, there are some syntax errors, so let's try this one. Okay, so if you want to Wolfram alpha here, remember that if you want to solve an equation, you need to use a double equality sign instead of the equality sign, okay? And if we solve this function, sine x equals log base 10 of x, as you can see here, there are three solutions of x, right? One of them is approximately 2.70. The other one is 7.33, and the last one is 8.26. So there indeed has three solutions, right? Okay, so I'll write it here. So the first one here is 2.70. The second one is 7.33. And next one is 8.26. And then we need to find the intervals that make sine x is larger than log base 10 of x. So this is our log base 10 of x, and the curve here is a sine x. So that means we need to find intervals that makes the blue curve above the red curve, right? So apparently there are two intervals. First of all is between 0 and 2.70. Okay, remember that the domain says x cannot be less than 0 or equal to 0. So x must be greater than 0. So this is the first interval we are looking for. Next, there is another interval which is from 7.33 and 8.26. In this interval, as you can see here, the blue curve is also above the red curve here, which means sine x is greater than log base 10 of x, right? So the final solution of this inequality is these two intervals. X is either greater than 0 and less than 2.70, or x is greater than 7.33 and less than 8.26. Okay, again, I need to specify this. Do not forget domain, okay? X needs to be greater than 0. Okay, you can also complete this task using a graphical calculator. I'm not gonna introduce the graphical calculator for you here. Please check your menu of the calculators after the class, okay? The principles of solving such problems are similar. Either you use a calculator or use some online tools such as the two are listed here, okay? Do try to this by yourself after the class. Okay, please have a look at the solution. Let me know if you have any questions, all right? All right, let's have a look at another example questions. So this time, this is a real world problem. So for a real world problem, pay special attention to the domain according to the actual problem, okay? A computer store cost C for shipping and storing n computers can be modeled by the function Cn equals 1.5n plus 200,000 over n. The storage capacity of the store's warehouse is 750 units. Determine the minimum and maximum number of computers that can be ordered at any time at any one time to keep costs below 1,500, assuming that inventory has fallen to 0. Okay, again, I'll give you 10 minutes to think about this question. And after that, we'll have a look at the solutions together. Okay, let's have a look at the solutions together. So first of all, we can let Cn less than 1,500 and solve for n, right? Okay, so note that the domain states that n needs to be greater than or equal to 0 and less than or equal to 750 because the storage capacity of the store's warehouse is 750 units. So n cannot exceed 750, right? And of course, because n stands for the number of computers, so that means n must also be an integer. Okay, so Cn is less than 1500 is equivalent to 1.5 n plus 200,000 over n less than 1500, right? Which is equivalent to 1.5 n square minus 1500 n plus 200,000 less than 0. So apparently this is our quadratic function, right? In order to solve this inequality, first of all, we can find its zeros. If you let this quadratic function be 0, and using the quadratic formula, it is not very difficult to find its two zeros. One of them is 158.43, and the other one is 841.57. And note here, this quadratic function is opening up, right? So the intervals that makes this function less than 0 is between the two zeros, which is between 158.43 and 841.57. And also note that n needs to be greater than or equal to 0 and less than or equal to 750. And also n needs to be integer. Therefore, the final solution is n is greater than or equal to 159 and less than or equal to 750. And n is an integer, okay? So this is a final solution of this question. Please have a look at the solution here and let me know if you have any questions, okay? So this is what we have learned for today. Let's revisit today's learning goals. After today's lesson, now you should be able to first understand that solutions to problems involving combined functions can sometimes lead to a range of acceptable answers. Once this happens, techniques for solving inequalities are applied. Second, understand that there are a number of ways to graphically illustrate an inequality involving a combined function. Third, understand that algebraic and graphical representation of inequalities can be useful for solving problems involving combined functions. So the rest of the time is reserved to complete and submit today's homework, okay? Remember to submit before deadline onto Google Classroom, okay? You can start doing today's homework now.